Okay, now let's do probably the hardest one in terms of u substitution in definite integrals. We're trying to find the definite integral from 2 to 5 of x over square root of x minus 1 dx. And again, I'm going to use indefinite integrals. Again, I'm going to pretend that there are no endpoints. So let's try to find the integral of x over square root of x minus 1 dx. Okay, of course, we're going to use u substitution, and u is going to be everything under the root, so just x minus 1. If you calculate du, then the derivative here is just 1, so this is equal to dx. When I replace those two into my indefinite integral, what I get is, well, it's the integral of x stays as it is, square root of u, and then du. And it seems that we didn't do the math right, because this x didn't cancel out. But this one is one of those cases that you can solve this equation, u equals x minus 1. You can solve it for x and replace it in there. So you can see that x is also equal to u plus 1 when you move the 1 over there. And you'll use that equation as well to change this integral into u plus 1 over square root of u du, like this. Okay. And now that we have a fraction, the only way to deal with it is to break it apart. So this is the integral of u over square root of u plus 1 over square root of u du. And this breaks up further into, well, it's u over square root of u, just gives you square root of u, and du plus 1 over square root of u du, like so. And I'm going to also change it into powers. So this is u to the 1/2 du plus u to the minus 1/2 du. And this gives you, when you do the integrals, u to the 3/2 over 3/2 plus u to the 1/2 over 1/2. Okay. But of course we have the plus c, and we need to change back into x's. So let me replace x minus 1 in here. So we got x minus 1 to the 3/2 over 3/2. So the 3 remains here, and the 2 goes up there. Plus, well, this 2 is going to go up, so 2 times x minus 1 to the 1/2 plus c. Okay, so that's my antiderivative. Now I will remember that it's a definite integral. And I'm going to find it from 2 to 5 of x over square root of x minus 1 dx. And this gives you, well, we'll take the antiderivative with c equals 0. So 2 times x minus 1 to the 3/2 over 3 plus 2 times x minus 1 to the 1/2. And we will evaluate this antiderivative from 2 to 5. Okay, so let's plug in x equals 5 first, and then x equals 2, and subtract the 2. So what we get is, first term, 2, 5 minus 1 to the 3/2 over 3, plus 2 times 5 minus 1 to the 1/2. All right, so that's the first term. Minus, we'll have to plug in 2 here. So 2 times 2 minus 1 to the 3/2 over 3 plus 2 times 2 minus 1 to the 1/2. All right, so that's your second term. Now let's go ahead and do the computations. It's 5 minus 1. This gives you 4. So this is 2 times 4 to the 3/2 over 3 plus, again, it's 5 minus 1, that's 4. 2 times 4 to the 1/2. Okay, so that's my first term. Minus, this gives you 2 minus 1 to the 3/2. That's just 1. So it's 2 times 1, 2. So 2/3 plus 2 minus 1 is 1. 1 to the 1/2 is 1, so that's a plus 2. Okay. Now, what's the 4 to the 3/2? Well, it's 4 to the 1/2, which gives you 2, and 2 to the 3 gives you 8. Times this 2, this is 16. So 16 over 3. 4 to the 1/2 is 2. 2 times 2 is 4. and then minus the 2/3, and then plus the 2, minus the 2. So you got 14/3, and 4 minus 2 gives you plus 2. So total 20/3, because 2 is equal to 6/3.